Thank you, Ryan, for the introduction. Please allow me to introduce PIMSoft and Sigmafine history. Sigmafine started in 1993 with KBC, while PIMSoft started in 1995 as a distributor of the OCSoft products, and through the years acquired the Sigmafine product from OCSoft. PIMSoft continues to grow its relationship with OCSoft as we now have a multi-layered partnership. PIMSoft has local presence in Italy, USA, and India. Our growth also includes the acquisition of Omicron, which has expertise in OCSoft product customization. Our mandate is simply to condition your process and business data so that it improves the effectiveness of the users, whether they are persons, other IT applications, or business processes. Today, let us see how Sigmafine can be applied in the polysilicon and semiconductor industries. Silicon is the second most abundant element found on Earth. Polysilicon is a pure, stable, and crystalline form of silicon made from metallurgical grade silicon. Polysilicon offers properties like other semiconductor materials, and therefore it is widely used in the manufacturing of solar photovoltaic cells and electronic components. Currently, over 350,000 tons of polysilicon is made around the globe every year. And as the demand grows, the production will likely grow with it. As with many industries, polysilicon industry has its own set of challenges. Polysilicon is produced in large batches, and there are many intricacies in the preparation and mixing of the reactor feed. Getting the right mixture of the feed is the key to making highly pure product. Also, being able to track the quantities of the movements as well as quantity and quality of the raw material tanks to be able to catch any issues early in the process. And finally, dealing with energy-intensive process. Polysilicon is produced with an energy-intensive process which is known as chemical vapor deposition, in which reactors are heated to thousands of degrees Fahrenheit to produce polysilicon. As with any energy-intensive asset in your plant, you want to make sure it is operating with great efficiency to keep the operational costs down. So before we go any further, let us talk about what Sigmafine is and how it works. Sigmafine is a data quality provider in the real-time digital infrastructure. It is an application that applies a data reconciliation analysis to a model that represents a facility. The data reconciliation analysis is simple. It calculates the inputs minus the outputs minus the accumulation equaling 0. Sigmafine is configurable to meet your company's requirements. Sigmafine server provides out-of-the-box set of calculations and analysis like mass, volume, energy, quality balances that can be configured per your needs. Sigmafine has add-ons to extend the basic server functionalities to enhance the user experience. In addition to the add-ons, it also provides extensions for multiple industries like LPG, LNG industries, and domain-specific calculations like energy, thermodynamics, and psychometrics. Sigmafine is scalable and can focus on a small facility with 250 assets or up to 20,000 assets. It is also reusable in the sense that you can use the same model to do mass balance, energy balance, and other analysis. There is no need to create different models for different requirements. Sigmafine is also auditable. All the actions can be tracked and traced, which helps to meet a lot of corporate requirements. To give an overview of how Sigmafine works, first we have to define a model and identify a scope as to what we're looking at. You could apply Sigmafine to a plant, a process unit, or an equipment. Apply engineering principles using basic calculations such as unit of measurement, mass to volume conversion, and other simple calculations, or apply more complex calculations such as thermodynamics, equation of states, and or property estimations. After this, apply multiple balance equations to find minimal adjustment to measure data. You can use different analysis rules such as mass, energy, and composition. And then use regression analysis methodology to get an optimal fit of the observed data with minimum adjustments using the equation that you see on the slide. Here we are trying to minimize the errors using tolerances that are set in place. On the left, you can see an example of a model on which the reconciliation is applied to. The model consists of different assets such as tanks, flows, receipts and shipments, heat exchangers, and other pertinent assets to your process. Also, Sigmafine doesn't just take measurements data, It also connects to other third-party systems for things like inventory, planning and scheduling, lab results, design data, and more. So you may be asking, how does Sigmafine address the challenges that I spoke about before, and how can it be applied to the industry? Well, with Sigmafine, you can go beyond the normal reconciliation tasks I spoke about in my previous slides. Sigmafine has a conditioning arm that allows the user to do material tracking, and with this, you can track and manage raw materials to the final product, allowing to know what goes on into the reactor feed. And also by applying Sigmafine applications like the intelligent movement management, track the quality of movements and take the guesswork out of movement planning, monitoring, doing calculations, and doing reporting of transfers. And lastly, with the built-in energy balance calculation and the thermodynamics extension, you can track asset performance. Now we will see how we can do each of these in the subsequent slides. Let's look at how tracking capability can be used to track the raw materials. Sigmafine does this by the use of material tracking analysis. As we discussed before, Sigmafine is a system that provides different analysis plugins and calculations. We can break the analysis into two categories, one being the balance consisting of mass, volume, energy, and component. The second type of analysis is tracking, which consists of material tracking and quality tracking. Let us talk about the material tracking analysis. This type of analysis uses the composition tracking solver, which brings in all the information such as mass and volume, the input material, and calculates the reconciled material compositions of flows and tanks. The results are then used to keep track of the material mixing qualities, allocate cost per batch, track material loans in an ownership context, or monitor inside the pipelines to avoid contamination. So how does it work? The tracking algorithm considers the following. First step is to execute the balance, the use of reconciled data for good results. Second is to collect all the movements within a certain time. This can be done setting a 24-hour period. Then we decide which elements are part of the calculation. We can use the same model to use for the balance. There's no need to build another model. In order to calculate the composition of the tank, flows, and the movements, the algorithm considers the way how the materials are mixed in each inventory. In case of inventories that are not directly measured, as this information is not always available, Sigmafine can calculate the inventory based on surrounding measurements, and then tracking analysis based on the results can calculate the material composition. And finally, the algorithm considers the history of the stage. Initial composition of the current day can be automatically be taken from the previous day. As mentioned before, the way materials are moved through the model is defined via a mixing model. You can pick the ideal mixing method based on the type of material and the mixing that will be taking place. Examples of such mixing models are well-mixed model, where you have tanks with homogeneous material, baffled model for tanks with internal baffle, which keeps the input and output separate until the end, makeup purge, where most of the input goes directly to the output line and only the excess is taken from the tank. Then you have first in, first out, where you have each packet of material coming out of the same order as it went in. And then finally, you have last in, first out, where each packet of the material is removed in the opposite order from when it came into the inventory. Let us see how material movement can be achieved in Sigmafine. Sigmafine offers an integrated way to plan, execute, manage, and report movements of intermediaries and finished products with the help of intelligent movement management, known as IMM. Based on the rigorous mathematical cross-checks, the IMM takes the guesswork out of the movement planning, monitoring, doing calculations, and reporting. IMM tracks the quantity of the movements as well as the quantity and qualities of the tanks in real time. This enables users to detect errors early in the process so a problem can be prevented. The analytical plugins included in the IMM can also highlight discrepancies between process data and manual declarations. Here are a couple of pictures showing how IMM shows the transfers that are happening and where the issues are based on color-coded messages. You can do this for an entire plant or specific areas within a plant. Also, operators have a graphical view of the movement situation from their desk in a familiar environment. Let us look at the benefits of the IMM. The IMM allows the connection of logistics, operations, and production reporting with one version of the truth. Everything happens in a single package. Also, you can eliminate guesswork, have accurate records of real transfer volumes in real time, catch errors before they happen, and decrease manual labor. Many balance gross errors are screened upfront, alarms raised for inconsistencies between movements and related tank delta stocks. Intelligent algorithm automatically calculates the quantities by looking at the related model structure. IMM also shares a database with Sigmafine, so it means that the same assets are shown or shared, making declared movements instantaneously. Also, eliminate the need to install another system to manage the transfers. Let us look at some of the IMM benefits. IMM allows you to connect logistics, operations, and production reporting with one version of the truth. Everything happens in a single package. With IMM, you can catch errors before they happen and decrease manual labor. Many balance gross errors are screened upfront. Alarms are raised for inconsistencies between movements and related tank delta stocks. Intelligent algorithm automatically calculates the quantity by looking at the related model structures. IMM shares database with Sigmafine, so it means the same assets are shared, making declared movements instantaneously available for the collection in the balance model. This allows to eliminate the need to install another system to manage your transfers. And lastly, with IMM, you can construct complex transfer reports of the last hour, last shift, last month, or even last quarter. Let us see how performance monitoring can be achieved through Sigmafine. Energy monitoring and management really wasn't a big priority 20 years ago. However, it is something that a lot of companies are looking at today. Companies now need to have a verifiable and auditable data, which can be used to be able to operate within the environmental permits and controls and ultimately maximize profits based on efficiency and energy savings. Sigmafine supports the ISO 50001, which is an internationally recognized system that controls energy management. It sets goals for increased energy efficiency, optimization of resources, and minimizing environmental influences. By using Sigmafine, the goal is to apply model-based reconciliation to energy-intensive equipment like a batch reactor we spoke about before. These batch reactors are heated up to thousands of degrees Fahrenheit and then cooled to produce polysilicon. It is estimated that the chemical vapor deposition and cooling process accounts for up to 90% of the electricity consumption. As this is a huge overhead for companies using this method, we'll want to make sure the assets needed for this process are running efficiently and be able to monitor the performance for reliability. By measuring and monitoring its daily operations, the plant managers then can improve accuracy of KPIs and improve overall plant operations. The requirement for performance monitoring are Sigmafine energy balance and thermodynamics extension. The energy balance and the thermodynamics extension can then be applied to a model of an equipment to be monitored. It could be a furnace, a compressor, a turbine, heat exchanger, or a reactor. After the analysis is performed, the results can then be made available via company dashboards such as PyVision or Power BI. So here you're looking at a furnace monitoring model, which contains different furnaces and the feed of the furnaces and the air and all the other assets. There is an analysis done here for the integrated mass and energy balance where a non-linear solution is applied and the calculations for the thermodynamics are implemented. So we have trustable data that is validated by the Sigmafine analysis. An accurate estimation of the flow properties is also achieved through Sigmafine and the thermodynamics extension. So we can finally have KPIs that are calculated and made more consistent by the Sigmafine analysis. Once the data is conditioned, it can then be published via a Power BI dashboard like the ones seen here in this slide. in accordance with the ISO 50001 to support the energy management decision making. The data is then calculated and automatically aggregated. It helps to improve real-time operations in the control room, support energy managers' daily activities, and lastly, the data is and or can be made available online and or by mobile devices. Another example of how data reconciliation can improve the accuracy of KPIs. Here we have data for industrial furnace. On the left, you see raw data that shows the poor correlation between the efficiency of furnace and the oxygen content in the flue gas. And on the right, after the reconciliation is done, you can see a good correlation between the oxygen content and in the flue gas efficiency. So from here, the engineer can better plan for the crude batches. So this is what we have covered today. Sigmafine can go beyond the regular mass balance tasks and with the help of different analysis, help with the company needs or requirements, also improve operations and help meet regulatory standards with the help of performance monitoring. And with this, I conclude my webinar and stay available for any questions you may have. Thank you for your time.